Vanakkam. Welcome to this course on Classics in Neuroscience. In this series of videos, we've been looking at functional organization of neurons. In the last few videos, we've been looking at the functional organization of dendrites. In this video, we'll look at how there was a need to rethink the grand concept of the neuron doctrine. So, in the 1950s, there was the integration of synaptic potential studies, action potential studies in axons, and also the study of dendrites and dendritic spines. Ramon y Cajal, when he came up with this idea of polarization, dynamic polarization, and directionality, he suggested that there was essentially information flow from dendrite to the axon, but he essentially relied entirely on histology. Remember, Ramon y Cajal was a histologist first, but later physiological, electrophysiological or neurophysiological evidence provided greater, deeper, more fine insights on what was actually happening. Theodore Bullock in 1959 reviewed this work, a whole series of electrophysiological studies that happened in the 1940s and 1950s, and he introduced the concept of complexity within unity, how a single neuron itself houses a lot of complexity within a single unit. In one unit, there was a complexity of how the action potential is being generated in the axon hillock and the action potential is being conducted along the axon, but also the graded potentials that you see in dendrites, functionally very different principles. So, there was this complexity within unity, and he suggested that neurons have different properties in dendrites and in axons. This idea was later called as a quiet revolution, so sweeping but quiet revolution. It suggested that impulse is not the only form of activity, action potential is not the only form of activity, and excitation may or may not involve the entire neuron. It is not necessary for the entire neuron to be excited in all the cases, and there are variations in how dendrites propagate impulses. There are very different forms of graded activity you can observe in pacemaker, synaptic and local potentials, and this was also integrated within the particular region that was being studied, some circumscribed regions influenced by historical and milieu. So, this he characterized as a sweeping but quiet revolution in the understanding of the concept of a neuron. This changed our understanding of how a neuron works or functions. Initially we thought a neuron is an individual unit and it works in this way. Later it became a lot more complex to describe. There are these dendrites, a whole bunch of dendritic branches and axons that conduct action potentials. Dendrites do not necessarily conduct action potentials, a whole complicated structure within one neuron. It is this complicated. Later there was also this demonstration of axonal synapses. Initially believed that synapses happen between axons and dendrites, but later there was a demonstration of axonal synapses and also dendrodendritic synapses, synapses that happen between two dendrites, synapses that happen between an axon and another axon. So, there were these proposals to replace the neuron doctrine, but rather what has happened was that different functional units were introduced at different organizational levels, at different hierarchical levels. So, Shepard introduced this concept of hierarchical functional units. This is what is being used to organize material in the textbook for the course. Also, in this entire course, this is how information is organized. Now, what is happening is there is an effort to incorporate classical neuron doctrine into these new concepts. So, there is a need to explore multi-level, multi-neuronal functional units. A lot of people are working on this line of work. These are all the references that we used for the past 7-8 videos. Please do check these papers, very interesting seminal contributions. With this, we come to the end of this video. In this video, we looked at how there was a proposal to rethink the neuron doctrine, and there was the introduction of hierarchical or functional conceptual units. Thank you for your attention.